In this video, we're going to look at how to add and subtract fractions. Now, first we look at these three examples here. And in these three examples, notice that all of these have, in each question, we have the fractions with the same denominator. For example, 4 and 4 here, 4 and 4 here, and 5 and 5 here. So this is the easy case. Now, how do we add then? If you think of this as 1/4 cup of water plus 1/4 cup of water, so we're going to get 1/4 plus 1/4, that literally gives us 2/4. So you can convert the fractional symbol into words. So it's like 1/4 plus 1/4. You can also think of them as coins. So 1/4 means 1/4 plus another quarter. So the answer would be, we know it's 2/4. So notice that the 2 comes from adding the numerators, the top numbers, 1 to 1. Maybe use a different color, so 1 to 1. So this one and that one, they are added. And because the reason why we call the numerator is because it tells us the number of coins we have. So how many coins we have. So let me change it to this color. So okay, so we have 1/4, and that's the number of quarters we have, and we have another 1/4, that's the number of quarters. So 1 plus 1, that gives us 2. And so the rule for adding fractions, we only add the numerators, because the numerator tells us the quantity. Again, numerator comes from the word number. So if I write down numerator, it literally comes from the word number, which is how many quarters do you have. So we add them. 1 plus 1 gives us 2. And notice that the quarter doesn't really change. So as you can see, quarter plus quarter, we still get a quarter. Although in English we have to turn that into the plural form, but it really doesn't change the value. So it's still going to be a quarter. So that's why the denominator 4 will stay. So we cannot add 4 and 4. So don't confuse this with multiplication. When we do multiplication of fractions, we do multiply the top and top and the bottom and bottom. But for addition, we cannot add the numerators. Again, for the reason that I explained, because quarter plus quarter, you still get quarter. So this 4, the value at the bottom, 4 and 4, they both indicate that's a coin. That's a quarter. The coin is a quarter. So it's or 1/4. So that's actually why we call the bottom number denominator, because it's the denomination of the coin is a quarter. Okay, so the rule is keep the bottom, 4 and 4, keep it. You still get 4, but we're going to add the numerators, 1 plus 1, that gives us 1 plus 1, that gives us 2. Now, in algebra, we always want our fractional answers to be in its simplest form. So we use what we learned before. If we check the top number and the bottom number, if they both have something in common, say 2 here, and we're going to divide both of them by 2, so they can be reduced down to 1/4, 1/2. So 2/4 actually equals 1/2, which is 1/2. So 2/4 cups of water are equivalent to 1/2 cup of water. All right, so next we can, the second example, we can do the same thing, the same way. So first of all, keep the bottom, 4, 4, 4, keep it as 4, stay as 4. But we're going to add the numerators, 1 plus 3, that gives us 4. So this is like 1/4. So here we have 1/4, and then we have 1/4. So top number is the numerator, tells us the number of coins we have. So 1/4 plus 3/4 and equals 1 plus 3. So we add numerators to get 4. In the bottom, the quarter stays the same. Again, the quarter doesn't change. So that's why 4, 4, 4 stays the same. And 4 over 4 can be actually reduced down to 1, because they both have a 4 in common. And we also know 4 divided by 4 equals 1. Okay, so finally, the last example, 5, 5, 5. We keep it as 5, but we're going to add 1 plus 2 to give us a 3. So we get 3/5. And if we put this in words, and it's also the same thing. If we have 1/5 plus 3/5, and we have 1 plus 3 to, I'm sorry, 1/5 plus 2/5, 1 plus 2 gets 3, and the fifth stays as 5th. Okay, so when we do addition, we need to make sure whatever we are adding. So we may be adding apples and apples, just quarters and quarters, and the quarters stays the same. Or apple will stay the same. Or fifth will stay the same, just like apple, 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 or quarter, quarter, quarter. And so the rule for adding fractions with the same denominator, we keep the same denominator. We only add the numerators. And make sure you don't add straight across. So don't add a 5 and a 5 to get 10. Again, because quarter plus quarter is still quarter. We're not going to get like something different coin. But most of the time, we are going to get fractions with different denominators. For example, 1/4 plus 3/10. A tenth, you can think of it as a coin, a dime, because 1/10 of if you divide $1 into 10 equal parts, you're going to get 10 cents, and that is because a $1 is literally 100 cents and 100 pennies. If you divide by 10, you get 10 pennies, which is a dime. So if you think of 3/10, 1/10 as a dime, and 1/4 is a quarter, and 3/10 is 3 dimes. So what we're adding 1/4 plus 3 dimes. We cannot add them. We cannot add 1 plus 3 to get, say, 4. 4 what? 4 quarters? That's incorrect. 4 dimes? That's incorrect. So we cannot really add them directly. So when we have different denominators, we cannot add them directly. So just think about this real life, the problem when we're adding coins. Everybody knows we cannot add quarter and dimes. They must have the same value. In order to make sure they have the same value, you will have to make sure the denominators, the bottom numbers, match. And right now, 4 and 10, they don't match. So how do we turn them into something that matches? So for example, 4 and 10, now they're different. So they represent different coins. But we can turn both numbers into a common number by multiplying some number. So for example, I can multiply 4 by 5 to get 20, and multiply 10 by 2 to also get 20. So if you say, how did you know you should use 5 and 2 to get 20? And this is something we already talked about, which is called the LCM. Now, how do we find LCM? We have 2 different solutions. So you can do, for smaller numbers like 4 and 10, I think a lot of us can already see they both can go into 20. But if you have trouble seeing that, you could do the factoring. So you break down 4 as 2 times 2. So a quick review of how to find LCM by factoring. So you break down 4, and then you break down 10 as 2 times 5. When you write down 2 and 5, you want to make sure you only put the same number in the same column. So 2 can be put in the first column because they match. But 5 cannot be put in here because 5 and 2, they don't match. So we're going to create a new column for that 5 and get rid of this. So, and again, 4 equals 2 times 2, 10 equals 2 times 5. Now to find LCM, you will bring down one number from each column. So now you multiply them to get 2 times 2 is 4, and 4 times 5 is 20. So that's how you get 20. If you have trouble seeing them, you can use this method. The other way is you can make a list. So you can list all the multiples of 4. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. And the problem with this method is you may not know when you should stop. But I guess when you write this, every time you write down a number, check whether it's also multiple of 10. And 4 is not a multiple of 10. 8 is not a multiple of 10. 12 is not a multiple of 10. 16 is not. But when you get to 20, you realize 10 also goes in there. So that's when you can stop. So either way, but again, I highly recommend the factoring method. This method works much better than the listing method when you work with big numbers. Okay, so we found the common number 20. So this is the number we're going to turn both denominators to. So you want to turn 4 to 20. And you also want to turn 10 to 20. And how do we turn 4 to 20? And notice that we need to multiply by 5. That's going to give us 20. And 10, we need to multiply by 2. But we cannot just take the bottom and multiply by a number, because that if we do that, and we were given a quarter, but if you turn just multiply by 5 and you turn 4 to 20, and the top is going to be, if the top stays the same, we're literally saying 1/4 equals 120, and that's apparently incorrect. And so if you get a quarter of a pie compared to you get 1/20 of a pie, they're definitely different portions. So we cannot just, if you have to multiply the bottom by a number, you must multiply the top by the same number. So we can also multiply the top by 5. In that case, if you increase both the top and the bottom number the same number of times, you still end up with the equivalent share, equivalent portion, or equivalent fraction. So the same thing here, if you multiply the bottom 10 by 2, you also have to multiply the top by 2. So after we do that, and you can see 4 times 5 is 20, 10 times 2 is also 20. So we're going to turn the bottom, both bottoms, to the same denominator. Again, I did it right here, and now you can see we have, so let me erase this. And originally we had 2 different denominators. Now we have 20 and 20. Now they match. So again, 1/4 cannot be added to 3 dimes. But 1/20th literally means value of a nickel, because it's 5 cents. So 5/20 means 5 nickels plus 6 nickels. Now they both are nickels. We can add them. So that's why it's very important when we do addition, we have to turn the denominators to the same number, because that will give us same type of coins, same values, and then we can add numerators. So again, when we do addition, we only add the numerators because they tell us how many coins we have. So 5 plus 6 gives us 11. So again, the rule is still going to be, even when they have different denominators, we still have to keep the denominator, but if they don't match, which one are we going to keep? So we have to first turn them into the same denominator 20, so we can keep 20 as the denominator and add the numerators.